A very good morning, Devinder. So, let's come to the today's topic. So, topic of today's class is calendar. We will discuss this particular topic first. So, the first concept of calendar is to understand the concept of odd days. So, what is an odd day? So, whenever we divide the total days by 7. So, okay. Whenever we divide the total days by 7, the remainder which we will get is called odd days. So when we divide the given number of days by 7, the remainder which we will get, this remaining days or this remainder is called odd days. See, if there is a question that how many odd days are there in 38 days? So how many odd days are there in 38 days? So if we have to find the number of odd days in 38 days, what we will do? We will divide 38 by 7. We will divide 38 by 7. Divide it. 7 5s are 35. So the final remainder is 3. So this final remainder is called odd days. This particular final remainder is called odd days. So, can we find out the number of odd days in 154 days? How many odd days are there in 154 days? How many odd days are there in 154 days? Okay, Mani is saying 3. Good. So we will divide it. So divided by 7. 7 2s are 14. 1 and 4 becomes 14 again. So 7 2s are 14. So the final remainder is how much? Final remainder is 0. Final remainder is 0. Okay? Now, if the final remainder is 0, it means there are 0 odd days in 154 days. 0 odd days are there in 154 days. 0. Yes. Okay. Good. So now, come to the question. Based on this particular concept, let's solve some questions. Suppose a question is, if today is Friday, then what will be the day? Then what will be the day after 75 days. So if today is Friday, then what will be the day after 75 days? See, what we will do. So whenever we need to move ahead, like here, how many days, what will be the day after 75 days? So whenever there is a term after, then we will add the value, add the number of days in 75, in Friday. So we will add 75 in Friday. So for adding 75 days, we will first try to find out the number of odd days, that how many odd days are there in 75 days. So for getting the odd days, we will divide this value by 7. So when we divide this value by 7, the final remainder is 5. Now we will add 5 days in Friday. Thus it will become Wednesday. Friday, add 5 days. The next day after Friday is Saturday. The next Sunday, Monday, Tuesday, and fifth day will be Wednesday. So the answer is Wednesday. So if today is Friday, then after 75 days, the day will be Wednesday. Okay. One more question. If today is Tuesday, then what will be the day after 174 days? So what will be the day after 174 days? Okay, Monday. Okay, very good. Monday. Tuesday. Okay. So today is Tuesday, and now we have to add 174 days in it. So we will divide 174 by 7. 7 2s are 14. Remainder is 3. 3 and 4 becomes 34. So 7 4s are 28. Final remainder will be 6. So we have to add 6 days. We have to add 6 days in Tuesday. So after adding 6 days in Tuesday, the day will be Monday. Add 6 days. So from Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Monday. The 6th day will be Monday. Yes. So the answer is Monday. Okay. Now, one more question. Move to the next type now. If 27th of March of any year is Saturday, so what will be the day? What will be the day on 17th of April of the same year? Of April of the same year. So here, 2 dates are given. The first date is of 27th March, and this particular day is Saturday, and we have to find the day on 17th of April of the same year. So what we will do, we will find the gap of number of days between these 2 dates. So we will try to find the gap between these 2 dates. So how can we find the gap? See, the month of March consists of 31 days. So we have to move from the first date to the second one. Means from 27th of March, we will move towards 17th of April. From 27th of March, we will move towards 17th of April. So how many days are left in March now? So the month of March is of 31 days and the date mentioned over here is 27. So the remaining days of the month March is of 4 days. So 4 days are remaining in March, and now the date which is mentioned in April is of 17th. Since these 2 months are consecutive months, so there are no month in between these 2 dates. So by adding these 2 number of days, we will get a gap of 21 days. And yes, so in 21 days, how many odd days will be there? So we will divide it by 7. Final remainder is 0. We will add this 0 on Saturday. So our answer will remain the same, that is Saturday. So whatever the number of odd days we find by calculating the number of days, we will add this particular day in the first day, that is Saturday, to get the answer. Now, let's solve one more question of this particular type. If 6th of April of any year is Friday, let's change the day also. And 25th of August of the same year will be 25th of August of the same year will be C. From 6th of April, we will move towards 25th of August. So 6th of April is Friday, and we have to find the day on 25th of August. So the date is of 6th and the month of April consists of 30 days. So the remaining days in April will be how much? So 30 minus the date, that is 6. So 30 minus 6, 24. So 24 days are left in April. Now, the months in between April and August are May, June, July. So these 3 months comes in between April and August. So we will have to add the number of days of each of the months. So the month of May consists of 31 days, that of June will be 30, and that of July will be 31. Now come to the date. So the date is 25th. Now add all these values, we will get 4 plus 1, 5 plus 1, 6, 6 and 5, 11, 3, 6, 9, 12, 14. 141 days. So there is a gap of 141 days between these 2 dates. Now, how many odd days are there in 141 days? So we will divide it by 7. 7 2s are 14, final remainder is 1. So, in 141 days, there are only 1 odd day. So we have to add this odd day in Friday to get the answer, and the answer will be what? Friday plus 1, that is Saturday. Friday plus 1, that is Saturday. So the answer of this particular question will be Saturday. Okay, one more question. If 17th of September of any year is Monday. 17th of September of any year is Monday, then 6th of June of the same year it will be, then 6th of June of the same year will be 6th of June of the same year will be which day? See, in this particular question, in the previous question, we were moving ahead, means from April to August. From April to August. But here, if you see that 17th September of any year is Monday. So the day of the month of September is given, and we have to find the day of the month of June. So how can we do this particular thing? See, it is quite simple. Always remember one thing, that we will always move from the first day or first date which appear in the calendar. So if we talk about these two dates, the first date which appear in the calendar will be 6th of June. Na? This date will appear first. So what we will do, we start from 6th of June and reach up to 17th of September. So from 6th of June, we will move towards 17th of September. To find the gap, so the month of June consists of 30 days, and here the day is 6. So the remaining days in June will be how much? 30 minus 6. 30 minus 6 is 24 days. So 24 days are left in June. Now, the month in between June and September are July, August. So in July there are 31 days. In August also there are 31 days. And the date mentioned in of the month of September is 17. Now add all the values. 4 plus 1, 5 plus 1, 6 and 7, 13. 3, 6, 9 and 10. So there is a gap of 103 days between 6th of June and 17th of September. Now we will find the number of odd days. So how many odd days are there in 103 days? 7 ones are 7. Remainder is 3. 3 and 3 becomes 33. 7 fours are 28. So the final remainder is 5. Now understand this particular thing, that the day of this particular date was given. That 17th of September is Monday. And from September we have to move towards June. Means in the calendar we are moving towards backwards. So for moving backward, what we will do, we will deduct 5 days from Monday. So we will deduct 5 days from Monday. So after deducting 5 days from Monday, what we will get? We will get Wednesday. So 6th of June of the same year is Wednesday. Monday minus 5, that is Wednesday. Very good, very good. Ashish, Rahul, Anamika, good beta. So now let's do one more question of this particular type, then we will move to the next type. So if 25th of December of any year is Sunday, then 16th of July of the same year will be, then 16th of July of the same year will be. So we will always start from the date which appears first in the calendar, and that date is 16th of July. So we will start from 16th of July and move towards 25th of December. And move towards 25th of December. So from 16th July to 25th of December. At first we will try to find the gap. So for finding the gap, so the month of July consists of 31 days and the date mentioned over here is 16. So 31 minus 16, remaining days is 15. So 15 days are left in July. Now the months in between July and December are August, September, October and November. So month of August consists of 31 days, September is of 30 days, October is also of 31 days, November is of 30 days. And the date which is mentioned for December is 25. So add these values, 5 plus 1, 6 plus 1, 7, 7 plus 5, 12, 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 3, 14 plus 2, 16. So there is a gap of 162 days. Now, how many odd days are there in 162 days? We will divide it by 7. 7 2s are 14, remainder 2, 2 and 2 becomes 22. So the final odd day will be how much? 1. So from 25th of December, which was Sunday, we will deduct 1 from it. Since we are moving backwards in the calendar, so whenever we will move backwards in the calendar, we have to deduct the day from it. We will deduct the odd day from the given day. So Sunday minus 1 will be what? Saturday. Sunday minus 1 will be what? Saturday. Yes. So the answer of this particular question is Saturday. Now, let's move to the next type. So at first we will try to understand this particular concept of odd days and see that how many type of questions can be framed by this particular concept only. Then we will move to the next concept. Ravi is 315 days elder than Sumit. Who is 55 weeks elder than Priya. Elder than Priya. If Ravi was born on Thursday, then on what day of the week was Priya born? Was Priya born? See, Ravi is 315 days elder than Sumit. So Ravi is 315 days elder than Sumit. And who is 55 weeks elder than Priya? Who means? So here who stands for? Sumit. So Sumit is 55 weeks elder than Priya. Sumit is 55 weeks elder than Priya. It means Priya is younger. So we are keeping the elder one above and the younger one below. And the gap between Sumit's birth and Priya's birth is of 55 weeks. So now, if Ravi was born on Thursday, okay. So the day on which Ravi was born is Thursday. So as we know that Sumit will born so Sumit took birth just after 315 days of Ravi. So after 315 days of Ravi means we need to add this particular number of days in Thursday. So for adding this, we will try to get the number of odd days first. So we will divide it by 7. 7 4s are 28. Remainder is 3. 3 and 5 becomes 35. 35 means the number of odd days will be what? 0. Number of odd days will be what? 0. So if Ravi was born on Thursday, then Sumit was also born on the same day, that is Thursday, because we have to add 0 in it. Similarly, if Sumit was born on Thursday, so after 55 weeks, Priya was born. So since here the gap is mentioned in weeks and a week consists of 0 odd days. So here 55 whole weeks are there. It means this also consists of how many odd days? 0 odd days. Since a week consists of 7 days and when we divide it by 7, the remainder is 0. It means a complete week consists of 0 odd days. So here there are 55 complete weeks. So in 55 complete weeks, the number of odd days will be 0. So we will add 0 again on Thursday. So the answer will remain Thursday only. Answer will remain Thursday only. Is it clear? So here we are all adding 0 days and here also we are adding 0 days. Now, so these were some questions which were based on the concept of odd days. So let's move ahead and try to find some other thing. So now in the next question, a particular date will be given and we need to find the exact day on that particular date. Yes, Devinder, we can also do the same thing, but as we know that a week consists of 0 odd days, so why we will make the things or stretch the solution. If a week consists of 0 odd days, then 55 weeks also consist of 0 odd days. So there is basically no need of that particular thing. You can do, but it is not required. Now come to the next concept. Here in this particular question, date, month and a particular year will be given, and we have to find the exact day. We have to find the exact day. So date, month and year will be given, and we have to find the exact day. So how can we find this? For finding the particular day, we have to make some calculations, and we have to use some code values for getting the number of odd days first, and from that particular odd day we can get the exact day of a particular date. So let's try to understand the code first. So we will start with code for century. Century code. So there are some centuries code which we have to keep in our mind, and we will start this century from 16th onwards, 16, 17, 18, 19, then 20, 21st, 22nd and 23rd. So this century code is repeated after every 4 centuries, and we need to remember this particular code value for century, that is 6, 4, 2 and 0. So this is the code of century first. Now we will move towards the code of months, that is January, February, March, April, May, June, July, August, September, October, November, December. As we all know that there are 12 months in a year, and basically there are 2 types of years. One which consists of 365 days, which can be said as a normal year or non-leap year, and the second one which is of 366 days, that is leap year. And as we all know that within a century, a leap year comes after every 4 years. So within a century, a leap year comes after every 4 years. So we have to remember this particular code also. For each of the month, that is 033614625035. This code value is of normal year. When we talk about leap year, the code of January and February only will change, and the rest code will remain the same. So the code for only these 2 months, January and February, will change in case of leap year, and for rest of the months, the code will be same for a normal year as well as a leap year. So we will remember this, and after calculating the odd days, after all the calculations, the odd day which we will get finally is called final odd day. So after doing all the calculations, the odd day finally which we will get is called final odd day, and on the basis of this particular final odd day, we will decide the day. See, as we all know that for getting the odd number of odd days, we have to divide the number of days by 7, and after dividing the value from 7 by 7, the number of odd days or the remainder will be any of these particular value. So if the final odd day is 1, that means the day is Monday, and if it is 2, it is Tuesday, and so on. So final odd day is 3, then the day is Wednesday, 4 Thursday, 5 Friday, 6 Saturday, and 0 Sunday. 0 Sunday. So now here, how can we calculate the final odd day? So for getting the final odd day, there is a very simple formula. We will try to put the values in the formula only and calculate it. And after getting the final odd day, we can decide the day. Now, what is the formula now? Let's see. Formula is very simple. Date, month code, followed by century code, followed by remaining year, and the number of leap year in that particular remaining year. The number of leap year in the remaining year. We will add these values and finally divide it by 7 to get the final remainder, which is called final odd day. So after dividing, the remainder will be called as final odd day. Which can be said as FOD in short. FOD in short. So this is the formula. In this particular formula, we will try to put the values in it to get the number of odd days and finally get finding the day of a particular date. So let's start with this particular question. Like, as we all know that today is 6th September and the day is Monday. So what we will do, we will try to find this particular day with the help of this particular formula. Okay. So let's try to find the day on 6th of September 2021. How we will calculate it, how we will put it in the formula. Let's see this. The first is date. Date which is mentioned is 6th. So now comes the month. Month is September. Code for September is how much? 5. So we will put 5 here. Now come to the year part. We will divide this year into 2 parts such that the first half will represent the century and the second part is called remaining year. So the first part is century and the second part is of remaining year. First part is century and the second part is remaining year. So the code, the century is how much? 20. So code for 20 is what? 6. Code for 20 century is what? 6. So we will put 6 over here. Now comes the remaining year. Remaining year is how much? 21. Remaining year is how much? 21. And finally, we will try to find the number of leap years in 21 years. As we all know that every 4th year within a century is a leap year. So for getting the number of leap years, we will divide the remaining year by 4. So when we divide the remaining year by 4, the quotient part will be how much? 5. 5 4s are 20. 5 4s are 20. So the quotient part is 5. So we will take the quotient part. Means there are how many leap years in 21 years? 5 leap years are there in 21 years. So I am repeating this particular thing again. The first is date. Second one is code of month. Third one is code of century. fourth one is number of remaining year, and finally the number of leap years in remaining years. So we will divide it by 4 to get the value 5. Now finally what we will do, we will add all the values and finally divide it by 7 to get the number of final odd days. To get the number of final odd days. So let's add 6 plus 5 is 11, 11 plus 6 is 17, 21 plus 17 is 38, 38 plus 5 is 43. So now to get the number of odd days, we will divide it by 7. So divide it, and what is the remainder now? 7 6 are 42, final remainder is 1. So if the final remainder is 1, it means this particular day is final remainder 1. It means the final odd day, value of final odd day is 1. So it means the day is what? Monday. So when the final odd day is 1, the day is Monday. Understood? Or do I need to repeat it one more time? Is there any need to repeat? Things are quite simple. We have to put the values in this particular formula, finally divide it by 7 to get the remainder. And from that particular remainder, we can select the day. That's it. Okay. Now one more question. So 27th of June 2015 was what day of the week? 27th of June 2015 was what day of the week? ये स्मेल मुझे ही आ रहा है, आपको भी आ रहा है, एक बार सुनिए तो. So 27th of June 2015 is what day of the week? Calculate it. Any trick to cross check whether we have written the code correct or not? The only way is to remember it, Devender. The only way is to remember it. There are only 12 digits for the code of month. Okay. Punita is saying Sunday. Mani K Thakur is saying Wednesday. Okay. Now let's start. The date is 27. Code for the month of June is how much? June is 4. Remember it? Now, code for 20th century is 6. Remaining year is 15. And in this particular remaining year, the number of leap years will be how much? Divided by 4. So the quotient part is how much? For 4 3s are 12. It means 3 leap years are there in 15 years. So there are 3 leap years in 15 years. Okay? Now divided by 7. So 27 plus 4 is 31. 31 plus 6 is 37. 37 plus 15 is 52. 52 plus 3 is 55. So now divided by 7. 7 sevens are 49. Final remainder is how much? 6. So the final remainder is how much? 6. So if the final remainder is 6, yes, Yashashvi, Dipanshu, final remainder is 6 now. If the final remainder is 6, it means the day is Saturday. Sir, why we will add month code when we are adding the days of a particular month? Okay, Mani is saying why we are using the code for a particular month if we are already adding the number of days in it. So can we use month code directly for finding the gap between the 2 months? Yes, Ashwara. We can use this particular method also to find the answer of the questions which we discussed previously. And I'll make you do that. See, the 27th day of which month is? June. So this is the 27th day of which month? That is June. Now, are all the dates same when we talk about January, February, March, April? So when we are using the same date, it doesn't mean that it is of same month. Since the months are different, we have to use code for a particular month also. So if we do not use the code for this particular month June, so this 27th date is of which month? Will not be clear, na? So only by adding 27 days, but if we will not use the code for month, then how will we understand that this 27th date is of which particular month? It can be any month, January, February, March, April, any of the month. So that's why for a particular specific month, we have to use this particular code value. Are you getting my point? So let's move ahead. Now, of August 1947. So 15th of August 1947 was what day of the week? See, it is very simple. Now, the date is 15th. Code for the month of August is 2. Now the century is 19. And for 19 centuries, the number of odd days is 0. Yes. 19th century, the number of odd days is 0. Now comes the remaining years and number of leap year. So in 47 years, there are 11 leap years. In 47 years, there are 11 leap years. So now we will add them and divide it by 7. So add these values. 15 plus 2, 17. 17 plus 47 is 64. 64 plus 11 is 75. So now divided by 7, we will get the number of odd days, which is how much? 5. So 5 odd days means day number 5 and final odd day number 5 is which day? Friday. So this 5 represents the 5th day of the week. That is what? Friday. So the answer is Friday. Okay? Now, one more question. Remember this, the code for the century which you are seeing over here. This is basically a cyclic value. It gets repeated after every 4 centuries. After every 4 centuries. Sir, any easy way to find out the number of leap years? Okay. See, this is the only way through which we can find the number of leap years. As we all know that within a century, every 4th year is a leap year, or the number of years which comes in the table of 4 are leap years. So within a century, these values will be what? Leap years. So if somebody is asking that how many leap years are there in 26 years, so you can count it on your finger. That is 4, 8, 12, 16, 20 and 24 till 26. How many values of a multiple of 4 are there? Only 6 values are there. So it means in 26 years there are only 6 leap years. So the best way of doing this is divide this value by 4. It is 6 4s are 24. So this 6, the quotient part, is called the number of leap years. Now, let's move to the next question. So 24th of February 2008. See, whenever a date of the month of January and February, remember these 2 months, whenever you find a date of the month of January or February, we have to check the year first, whether that particular year is a normal one or a leap one. So we will check the value of year, whether it is a normal year or a leap year. So for checking the value of a particular year, we will try to divide the value of remaining year by 4. If it is completely divisible by 4, it means the year is a leap year. And if we find some remainder in it, it means this particular year is a normal year. Okay, Mani K. Thakur is saying, sir, if we divide given years by 4, then the quotient sometimes do not give the exact number of leap year. See, Mani, what I am trying to say is, we will try to find out the number of leap years from the remaining year part, not overall. Not overall. We will try to find out the number of leap years from the remaining year part, not from the overall year part. So every time when you try to find out the number of leap years from the remaining years, what you will do, you will divide it by 4 and the quotient part will be the number of leap years only. We are not trying to find out the number of leap years from the overall year. Okay? So, since this value 8 is completely divisible by 4, it means this particular year is a leap year. So this value is completely divisible by 4. It means this particular year is a leap year. So we will use the code of the month of February of a leap year. So we will use the value of this particular code of a leap year. So code for February of a leap year is how much? 2. So just remember this. Here the code for February will be what? 2. Yeah. Devender, yes. Yes. In case of the number of leap years, Devender, we need not to check the remainder part. We have to always take the quotient part. Yes. So now the date is 24th. Code for the month of February will be 2 now because it is a leap year. And for 20th century, the code value is 6. We will take it from here. Now the remaining year is 8. And in 8 years, how many leap years are there? So the number of leap years will be how much? 2. Now add these values and divide it by 7. It will never fail, money. It will never fail. Okay? So adding these values, we will get, I think, 42. 24 plus 2 is 26 plus 6 is 32 plus 8 is 40 plus 2 is 42. So now divided by 7, final remainder is 0. Final remainder is 0 means the day is what? Sunday. So this particular day is Sunday. Is it clear? Okay, now. So this was the process of finding the day. Now move to the next type, where you will you will get the value of month, year and days. You will get these 3 informations, month, year and days, and on the basis of this we have to find out that particular date. So month, year and day will be given now, on the basis of which we have to find the exact date. So let's see how can we find this. How can we find the exact day? So the question will be like this. Second Saturday of April 2020 falls on which date? Falls on which date? Or was what date? So second Saturday of April 2020 falls on which particular date? So here, now we have to find the date. How can we find the exact date? So now month is given and year is given, and we need to find the exact date. So how can we find it? See, whenever you will find a question like this, what we will do, we will put date as 1. Here we will put date as 1. Always remember this. Always we will do the same thing. We will put date as 1. So we will try to find out that 1st April 2020 was what day of the week? Can we find it? Can we find the day of 1st of April 2020? So let's see how can we do this. So the date is 1 now. So code for April. Code for April is 6. Century part is 20. So code for 20 century is 6. Remaining year is 20. And in remaining year, there are 5 leap years in it. There are 5 leap years in it. Add all of them, divided by 7. So 1 plus 6 is 7. 7 plus 6 is 13. 13 plus 20 is 33. Now 33 plus 5 is 38. Now divided by 7, you will get final remainder as 3. 7 5s are 35, remainder 3. 3 means day number 3, and the day number 3 is what? Wednesday. Day number 3 is what? Wednesday. So now, we know that 1st of April of 2020 is Wednesday, and we have to find the date on Saturday. Yes, 1st April is Wednesday now, and now we have to find that Saturday falls on which particular date. So we will try to find the gap between Wednesday and Saturday. So from Wednesday, how many days we have to move? We have to go ahead to reach Saturday. So from Wednesday to Saturday, how many days are there? So Wednesday, from Wednesday, we will start counting Thursday, Friday, Saturday. So after 3 days of Wednesday, we will get Saturday. So here we have to add 3 on Wednesday. Same day we will add on the date also. So we will add 3 on the 1st of April. So we will reach on 4th of April. So 4th of April is Saturday, or you can say 4th of April is first Saturday of the month. 4th of April is first Saturday of the month. So 4th of April is first Saturday of the month, and we have to go to the second Saturday. So for finding the date of second Saturday, we all know that a week consists of 7 days. So we will add 7 in it, and thus the date becomes 11th. So 11th of April will be the second Saturday of the month. 11th of April will be the second Saturday of the month. So the process is, at first we will try to find out the first day of the month, and now when we get the day of the first day of the month, now we will try to find out the gap between the first day of the month and the given day. We will add the same value on the date also to reach the answer. Is it clear to all? Now, let's try to solve one more question of this particular type. third Friday of September 2025. September 2025. Falls on which date? Falls on which date? Nineteenth of September. Okay, Dipanshu. Okay, Devinder is also saying 19th. Okay, Devinder. So, very good. So, we will first try to find the day on 1st of September 2025. So, let's try to find it. Code for September is 5 now. Code for 20th century is 6 now. Remaining year is 25. And the number of leap years in 25 year is how much? 6. 6 fours are 24. Now divided by 7. So 6 plus 1 is 7, 30, 36. So the day is Monday. So 1st of September is Monday now. 1st of September is Monday. So first day of the month is Monday, and we have to go to Friday first. So after how many days Friday will come? After 4 days now. From Monday, after 4 days, we will reach at Friday. So 1 plus 4, 5th. So the first Friday will be on 5th. So the next Friday will be on after 7 days from 1st. And the third Friday will be after 7 days, 7 more days from the date. Means 7 plus 7, 14, 14 plus 5 is 19th. So third Friday will fall on 19th of the month. Yes. Third Friday will fall on 19th of the month. So I guess these things are clear now. So let's move to another type, which is called case of reference date. Case of reference date. So if 29th of July 2009 was Monday, then 13th of October 2017 was what day of the week? Was what day of the week? So how can we find this particular thing? How can we solve this particular question? See, here the term is if. It means the information which is given over here can be correct or incorrect. So at first we will try to find the correct day of 29th of July 2009 first. So we will try to find the correct day of this particular date. Can we find it? Yes, we can. Now the date is 29th, code for July is 6, code for century is also 6, remaining year is 9, and number of leap years in 9 years are how much? 2. Now divided by 7. 29 plus 6, 35. So 9 plus 6, 15. 15 and 2, 17. Now divided by 7. You will get the final remainder 3. 3 means Wednesday. So the actual day on 29th of July 2009 is Wednesday. So the correct day is what? Wednesday. But the day mentioned over this particular question over here is what? Monday. So from Wednesday, how can we reach Monday? Means there is a gap of how many days between Wednesday and Monday. So we can say that if we move 2 days before Wednesday, we will reach at Monday. So from actual day, we need to deduct 2 from it to get this particular day. Is it clear or not? So what we have done? We have tried to find out the actual day on 29th of July 2009 and we got it as Wednesday. But the day mentioned in the question was Monday. So from Wednesday, if we have to reach Monday, we will try to find the gap between Wednesday and Monday. You can say Wednesday minus 2 is Monday, or you can also say Wednesday plus 5 is Monday. Wednesday plus 5 is Monday. So from the actual day, either we can deduct 2 days or we can add 5 days to get our answer. Okay. So now we will try to find the exact date on 13th of October and we will make the same difference either by adding 5 or deducting 2 to get the day as per this particular information. So the date is 13th, code for October is 0. Century's code is 6, remaining year is 17, and in 17 years, how many leap years will be there? So the answer is 4 leap years are there. Add these values and divided by 7. So 17 plus 4 is 21. 13 plus 6 is 19. So when we divide it by 7, we will get 5 odd days. 5 means Friday. So actual the day is Friday. So actual day on 13th of October 2017 is Friday. But as per the first condition, we have to either deduct 2 from it or add 5 in it. So when we will deduct 2 from Friday, we will reach at Wednesday. Friday minus 2, and the day is what? Wednesday. Yes, Devinder. Maniket Thakur, good. Yashashvi. So from the actual day, we will deduct 2 from it. Since we are deducting 2 from this for the first day, first particular date, so we will do the same thing on the second date as well. So we will try to make the same difference to get the answer. Is it clear? So let's do one more question now. Okay. If 12th of January 1955 was Monday, then 11th of November 2135 will be what day of the week? Will be what day of the week? So try to find out the actual date on 12th of January 1955. Actual day of 12th of January 1955. Then find the difference between the actual day and Monday and apply the same difference on the correct day of 11th of November 2135. Okay. So Dipanshu Kohli is saying the answer is Thursday. Good, Dipanshu. Let's see. So at first we will find the actual day of 12th of January 1955. Okay, Devinder is saying Sunday. Okay. So Dipanshu is saying Thursday and Devinder is saying Monday. Okay. So 12th of January 1955 is what day of the week? So the date is 12th, code for January. Remember this? This 55 since this value is not a multiple of 4, so we can easily say that this is a normal year. So now we will use the code of January of the normal year, that is 0. Now code for 19th century. Code for 19th century is also 0. Remaining year is 55. Now the number of leap years divided by 4. 13 leap years are there. So add all the values and divide it by 7. So 55 plus 12 is 67. 67 plus 13 is 80. Now when you divide it by 7, you will get 11 sevens are 77. Final remainder is 3. Final remainder is 3. Okay. So there is a doubt, sir. Can you please explain why are we not adding the complete codes of 29th of July 2009 and adding only few codes and then divided by 7? See, we are not adding only few codes. We have to see that which month is there in the question and what is the year mentioned in the question. So the month and year. So we will take the code of that particular month only. There is no need to add all the codes of all the months to reach July. It is already added and developed and converted into a code. So all the days from January till July is added and then it divided by 7 to get this particular code value and finally converted into the code value. So that's why whenever we have to reach July, we will directly use the code of July if we talk about month. Similarly, when we talk about year, like you mentioned the year was 2009. So here we will divide this particular year into two parts. First part is of century and second part is of remaining year. Apart from century, how many years left? So here the century is 20. So for 20th centuries, the number of odd days which has already been converted into code, that is of 6. So for 20th century, we will use 6 and we are adding the number of remaining years in it as it is and finally trying to find the number of leap years in 9 years. So there are how many leap years in 9 years? There are only 2 leap years in 9 years. Before it, the month was of July. So for the month of July, we will use this particular code only, code for July only. And whatever the date was 29. So we are adding 29 in it. So we are using this particular formula. We are trying to place the values in this particular formula to get the answer. So the number of days of each of the month is already been added and then converted into the code. I guess it is clear now. Tressa? So, where we were? Okay. At this particular date, that is 12th of January 1955. So, 12th of January 1955, the actual day is Wednesday. And what is mentioned for this particular date in the question is again Monday. So from Wednesday we have to move to Monday. So for that, either we can deduct 2 from Wednesday to reach Monday, or we can add 5 days in Wednesday to reach Monday. We can do any of the thing, either deducting 2 from the actual date to reach on Monday, or we can add 5 days in Wednesday to reach on Monday. Yes. According to the condition, Swapnil, the answer is Tuesday. Yes, we have to deduct 2 from the actual day. So now, let's try to find out the actual day of 11th of November 2135. So now the date is 11. Code for November is 3. So for 21 centuries, century number 21, the code value is 4. Now, the remaining year is 35, and in 35 years, there are 8 leap years in it. So the number of leap years in 35 years is 8. Now, divided by 7. Since any number of days is in a multiple of 7, we can easily delete it. Like here also 11 plus 3 is 14. 14 is a multiple of 7. So we can also delete this particular value. Now 4 plus 8. Remaining days are 12. So finally divided by 7 we will get 5. 5 means the day is Friday. 5 means the day is Friday. So actual day is Friday now. Actual day is Friday now. So 11th of November 2135 is Friday, and from Friday we will deduct 2 from it. So Friday minus 2 days will be what? Wednesday. Friday minus 2 days will be what? Wednesday. Is it clear? So, correct day was Friday. As we have seen over here that we have to deduct 2 from the correct day to get our answer. We have done the same thing over here as well. We will deduct 2 from Friday to get the answer. Is there any doubt? So one more question, final one. Of this particular type, then we will move to the next type. So solve this particular question now. If 12th of May 2055 is Saturday, then 6th of November 2017 was what day of the week? Okay. Okay. You wanted to ask that particular thing. Now I got. Since only a few codes, not and divided by 7. See, the date is 12th of May 2055. So date is 12th. Code for May is 1. For 2000 years, 6 odd days are there. Remaining years is 55. And this in this particular remaining years, the number of leap years will be how much? 13 leap years are there, I guess. 13. Okay. Now, we have to deduct this particular value by 7. Now, Teresa, I got your question now. Since we have to add all the values and finally divide it by 7 to find the remainder of the value. So, since if any of the value which is mentioned in the numerator is in a multiple of 7, if any of the number of days or any of the number of codes is in a multiple of 7, this will give you 0 odd days. Like, how many odd days are there in 7 days? How many odd days are there? So when you divide it by 7, the remainder will be 0. In 14 days, how many odd days are there? If you divide it by 7, the remainder is 0. In 21 days, how many odd days are there? We will divide it by 7, the remainder is 0. So if any of the value is in a multiple of 7, this will fetch you 0 odd days. This will give you 0 odd days. Means this will not create any impact on the number of odd days or the answer of the question. So since any of the day, if any of the day is in a multiple of 7, we can easily delete it, or you can say like 55 plus 1. 55 plus 1 becomes 56, and since 56 is a multiple of 7, 7 8s are 56, it means adding these two, you will get the number of odd days 0. So 56, the total number of days is 56. This 56 days will have no impact on the number of odd days. So that's why what we can do, we can delete it. So if any of the value is in a multiple of 7 or becomes in a multiple of 7, you can easily delete it. It will make your calculation a bit easier or faster. It will make your calculation a bit easier or faster, and that's it. Like 55 plus 1 is 56. We deleted these two values since it is a multiple of 7. Now we will add the remaining values only. Like 12 plus 6 is 18. 18 plus 13 is 31. Now divided by 7. The final remainder is 7 4s are 28. Final remainder is 3. Since the final remainder is 3, means actually the day was Wednesday. The day is Wednesday. So actual day is Wednesday, and the day mentioned in the question is Saturday. The day mentioned in the question is Saturday. So when we have to move from Wednesday to reach Saturday, how many days we need to add in it? 3 days. From Wednesday we will add 3 days to get Saturday, na? Wednesday, Thursday, Friday and Saturday. So we have to add 3 in the actual day to get the answer. So here also we will try to find the actual day of 6th of November 2017. And after getting the actual day, we will add 3 in it to get the exact answer. So the remaining year is 17, and in 17 years, there are 4 leap years. So the number of leap years in 17 years is how much? 4. Now again, you can see 17 plus 4 becomes 21. 17 plus 4 becomes 21. 21 is a multiple of 7. No need to add this particular value. We will add the remaining value. 6 plus 3, 9, 9 plus 6, 15. And when you divide it by 7, the final remainder which we will get is 1. So the final remainder is 1. 1 means actual it is Monday. But we have to add 3 in the actual day. So by adding 3 to Monday, we will get Thursday. Monday plus 3 is what? Thursday. Is it clear? Is there any doubt? Okay. So we could have done the same thing in one of the previous questions where the year was not mentioned. Only date and month were mentioned and year was not there. So we can solve that question also using this particular method or using the formula. Like, question was, if 29th of May of any year was Friday, let's say, or is Friday, then 16th of November of the same year is what day of the week? Of the same year is what day of the week? Same year is what day of the week? So try to find the answer of this particular question using the formula. Since year is not mentioned in this particular question, so we will try to apply the formula till month only. So date, month and divided by 7, find the remainder and check the actual day and the difference between the actual day and this day, that is Friday, and apply the same thing on the second particular date. So for 29th of May, date is 29th and code for May is 1. Code for May is 1. Add these two and divide it by 7. 30 divided by 7 is, the remainder is 2 now. 2 means we can say it like it is Tuesday. So actual day which we are getting for this particular date and month is Tuesday. But the day mentioned over here is Friday. So to make it Friday, we have to add 3 in it. Tuesday plus 3 is Friday. Wednesday, Thursday, Friday. So we have to add 3 in it. So now we will do the same thing with the next date, that is 16th of November. So date is 16th. Code for November is 5. Now divided by 7. 16 plus 3 is 19. So 19 divided by 7, final remainder is 5. 5 means the day which we are looking for is Friday, and now we have to add 3 in it. So after adding 3 in Friday, we will get Monday. So if 29th of May of any year is Friday, then 16th of November of the same year will be what? Will be what? Monday. Will be what? Monday. So we can solve this question using both the methods. The first method was try to find the gap between these 2 days, the gap of number of days between these 2 dates. And the next thing is by applying the formula, and by applying the formula also we can solve this particular question. So is it clear or not? Since the year was not mentioned, so we do not have to apply these three things in this particular question. We will use this formula till the month only. Yes, Devender. Very good question. Devender is asking that, sir, in the same question, if the month is January, then which one to consider? Means the code of January. Whether we will use the code of normal year or a leap year. See, whenever you find the month of January and February at any of the two places, it must be mentioned in the question that we need to consider that year as normal or leap year. It should be mentioned in the question. Then only we can apply the code for respective particular months. Are you getting my point, Devinder? So if at any of these two places, if you will find a month of January or February, so it should be mentioned in the question whether we have to consider it as a case of normal year or a leap year. Got my point, Devinder, na? Okay, now. So the next part which we have to study over here is of matching calendar. Or you can say similar calendar. So two types of matching can be asked to you. Matching or similar. Similar calendar. So there are two basic types of matching calendar, or you can say similar calendar. The first case is of matching months, and second case is of matching year or similar year. Matching month means 2 months which have the same date and day of a year. Any 2 months of a year which have same date and day. So for getting this particular matching months, we will try to take the help of the code values. These code values. So it is very simple to find the matching months of a particular year. Okay? The months of which the code values are same, they are also matching. The months of which the code values are same, it means they are matching months. Like, if you see the code for January is 0 and that of October is also 0. So these 2 months are having the same code values. So if the 2 months are having the same code value, it means the calendar of January will match with the calendar of November. So on any particular normal year, if let's say, if 1st of January of a normal year is Monday, then it also means that on 1st of November also of the same year the day will be Monday. So 2 months which are having the same date and day. 2 months which are having the same date and day are called matching months. Got my point now? So since these 2 months are having the same code value, it means their calendar will match with each other. Similarly, the next matching value is what? 3. You can find 3 in the code of February, March, and as well as November. Sorry, here October. My mistake. The code of January and October are matching now. So this, yeah. It should be October with Jan. Yes, Dipanshu. I did a mistake. Sorry for that. So code of January and October are same. So these 2 months are having the same date and day. Similarly, the next matching months are February, March, and November. February, March, and November. Similarly, the next matching values are 6 of April and July. So calendar of April will match with July. Calendar of April will match with July. And one more matching value is there, that is 5, which is of September and December. September and December. September and December. So got my point? So the question will be written like this, that which of the 2 months are having the same calendar? Which of the 2 months of a year are having the same calendar? So in one of the options, you will find any one of these 4 options, these 4 values, any one. So that particular months will be the answer. No, this particular combination is for a normal year. So when the question will ask you about leap year, you need to change the code of January and February to 6 and 2 and then see the matching. Then we have to do the same thing. So for a leap year, the code of January and February will change, and from that we need to check that like for a leap year, the code of January will match with April and July. So for a leap year, the code of January will match with April and July. And that of February will match with August. So these 2 additional pair will be formed in case of leap year. Okay. Now the third will be of March and November, and April and July will remain the same. April and July, which is mentioned over here only. And finally September and December. Usually the question are asked of a case of normal year, means non-leap year. So when you put the code of January and February as 6 and 2, so this will become the code for leap year, and in leap year we will have to do the same things. We will have to find the same code values, the months which are having the same code values, and for that particular month which are having the same code values, their calendar will match with each other. Yashashvi? So this condition is for normal year and this condition is for leap year. Okay, so let's move to the next matching value, and that is of matching year. For finding the matching year, for getting the matching year, we will start checking it from a leap year. Okay. So a calendar of a leap year is repeated after 28 years. It got repeated after 28 years. So a calendar of a leap year is repeated after 28 years. So the question will be like this. That the calendar of which year will match with 2020? The calendar of which year will match with 2020? So since 2020, 20 is a leap year. The value 20 is a leap year. So since it is a leap year, its calendar will match after exactly 28 years. Means the calendar of 2020 matches with 2048. Matching year means 2 years which are having the same date, day and month. Okay? So the calendar of a leap year matches after every 28 years. Okay. When the year is immediate next year to a leap year, or you can say year is first year from a leap year. So if a year is the next year of a leap year, its calendar will match after 6 years. The calendar of this year will match after 6 years. Like the calendar of which year will match 2021? The calendar of which year will match with 2021? So the answer is quite simple. Since 2021 is the next year of a leap year, we have to add 6 in it. Means the calendar of 2021 will match with 2027. 2027. Okay, so we can use this year's calendar in which particular year? We can use the same calendar in 2027 as well. Okay, so if today is 6th September 2021, so 6th September 2027, these two dates will have the same day. So if today is Monday, we can easily say that on 6th of September 2027, the day will be Monday only. The day will be Monday only. And if the year is second or third year of a leap year, second or third year of a leap year, so their calendar will match after 11 years. So their calendar will match with the year which is exactly after the 11 years of the year. Like if the question will ask us about the matching calendar of 2022. So since 2022 is second year from a leap year is 2020. So 2022 will be second year from a leap year. So its calendar will match with match exactly after 11 years. Means the calendar of 2022 will match with 2033. And similarly, the calendar of 2023. So now 23 is third year from a leap year. Leap year was 2020. So 1, 2, 3. Since this is third year from a leap year, its calendar will also match after exactly how many years? 11 years. So now the next year after 2023 will be 2024, which is again a leap year. So now these values will get repeated in a cyclic order. Okay? For a leap year, first year, second year, third year. After it, again the year will be a leap one. So we will add 28 in it, then 6, 11 and 11. So 28, 6, 11, 11, this is a basically cyclic value from a leap year to a leap year in case of matching years. So I guess it is clear now. So let's take a short break, then we will continue this particular topic. Okay? Okay then. Thank you very much. So welcome back. So let us discuss some questions based on calendar. So question number 1. If 9th of a month falls on the day preceding Sunday, on what day 1st of the month will fall? Easy question, quite easy. So 9th of a month falls on the day preceding Sunday. Preceding Sunday means Saturday. The day before Sunday. That is Saturday. And we have to find the day of 1st of that month. 1st of that month means we need to move 8 days before the date of 9th. So we will try to find the odd days in it, and the number of odd days which we got is 1. Since we are moving ahead, we will deduct 1 from Saturday also. So we can easily say that 1st of a month is on Friday. 1st of a month is on Friday. Diksha, okay. So one more question is there from the doubt section, that is, if the third day of a month is Monday, which one of the following will be the 5th day from 21st of the month? So let's see this question now. If the third day of a month is Monday, third day of the month is Monday, so third day is Monday. Which of the following will be the 5th day from 21st of this month? So let me write down the question first. If the third day of the month is Monday, then what will be? So which of the following will be? Which of the following will be? Fifth day from 21st of this month. From 21st of this month. So what will be the answer? So in question number 1, the answer was Friday, na? Okay. Now let's see this particular question. Anyone wants to answer? Mani, Punita, Anamika, Nadeem. Anyone wants to answer this particular question? It is very simple. See, third day of a month is Monday. Third day of a month is Monday. And which of the following will be the fifth day from 21st of this month? So we need to find the fifth day from 21st of this month. It means we need to find the day of which particular date. See, what we will do, we will add these two to get the date, and that date is 26th. 26th. So can we find the day of 26th of the month if third of a month is Monday? So, are you getting my point? But remember one thing. Here is a term that is called from. So whenever this term from is being used, so the first day from 21st will be 21st itself. So when this word from is mentioned over here, we will start our counting from 21st only. Means basically what we need to do, we need to add these two values. And since the first day is 21st only, so what we can do is 21 plus 5 minus this particular day, means the exact day which we need to find is of 25th, not 26th. Got my point? Not 26th. Since the term from is mentioned over here in the question, it means we have to start our counting from 21st only. So the 21st is the first day. So if we are counting from 21st, then 21st has to be considered as day number 1. So similarly, day number 2, 3, 4, 5. So fifth day will be 25. So we have to find. So we have to find the day of 25th. So since there is a gap of 22 days, means one odd day. So the answer will be what? It should be Tuesday. It should be Tuesday. So the answer mentioned over here should be Tuesday. Now come to question number 2. See this particular question now. So, Anil reached a place on Friday. He came to know that he was 3 days earlier than the scheduled day. If he had reached there on the following Sunday, how many days late early he would have been? So, Anil reached a place on Friday. So, on this day, Anil reached there. He came to know that he was 3 days earlier than the scheduled day. So, the scheduled day will be 3 days from Friday. So, Friday, 3 days after Friday. Saturday, Sunday and Monday. So Anil reached on Friday, but the scheduled day of the meeting was Monday, 3 days after Friday. 3 days after Friday. So Saturday, Sunday, Monday. So the scheduled day was on Monday. Scheduled day of the meeting was Monday. Now, if he had reached there on following Sunday, how many days late or early he would have been? So, instead of Friday, if he reached there at Sunday, then he will be 1 day before, a day before, or you can say a 1 day earlier than the scheduled day. So the scheduled day was on Monday. So if he had reached on Sunday, it means he is 1 day earlier than the scheduled day. So here the answer will be 1 day earlier. 1 day earlier. Now, move to the next question, which is, if 3 days before yesterday was Friday, what will be the third day after the day after tomorrow? What will be the third day after the day after tomorrow? So if day before yesterday was Friday, so we can solve it like this. Let's say this is today, this is yesterday, and this is day before yesterday. So day before yesterday was Friday, and we have to find what will be the third day after tomorrow. So day after tomorrow. So at first we will reach at day after tomorrow, day after tomorrow, and from here we have to count third, first day, second day and third day. So we have to find this. We have to find this. So if this is Friday, then this is Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday again. So the answer is what? Friday only. So if day before yesterday was Friday, then 3 days after the day after tomorrow will be Friday again. So the answer is Friday. Got my point? Now, move to the next question. That is, if the day before yesterday was Sunday, then what will the day of what day it will be? 3 days after the day after tomorrow. This is almost the same thing. So here the day before yesterday was Sunday, and 3 days after day after tomorrow. So today, tomorrow, day after tomorrow, and 1, 2, 3. 3 days after the day after tomorrow. It means it is again the same day, that is Sunday. So the answer of this question is Sunday. Okay? Now next, Suresh was born on 4th of October 1999. Shashikant was born 6 days before Suresh. If the Independence Day of the year fell on Sunday, which day was Shashikant born? Which day was Shashikant born? See, Suresh was born on 4th of October. Suresh was born on 4th of October. And Shashikant was born 6 days before Suresh. 6 days. So 1, 2, 3, 4, 5, 6. So Shashikant must have born on 28th of September. 6 days before, from where? 6 days from where? 4th of October. So 6 days from 4th of October. That is 28th of September. Now, the Independence Day of the year fell on Sunday. So Independence Day means 15th of August. Independence Day means 15th of August. So 15th of August was falling on Sunday. Then Shashikant was born on what day of the week? Means we have to find Shashikant's birthday, that is 28th of September will be which date if 15th of August is on Sunday. So how many, means there is a gap of how many days? So in the month of August there are 31 days. So 31 minus 15. So the remaining days are 16. So remaining days of August are 16, and in September we have to go 28 days further. So since it is a multiple of a 7, it need not to be added. Divided by 7, remainder is 2. Means if this is Sunday, then this will be Sunday plus 2, means Tuesday. Means Tuesday. So the answer is Tuesday. Okay. Now come to sixth question. Question number 6. If the 23rd of a month is on Sunday, what day it would have been 2 weeks and 4 more days earlier? So if 23rd of a month is Sunday and we need to move how many weeks? 2 weeks and 4 more days earlier. Earlier, so for going backward earlier, we have to deduct the number of odd days from Sunday. So here the gap is of 2 weeks and 4 more days. So from Sunday we have to deduct 2 weeks and 4 days. Since a week consists of 0 odd days, so 2 weeks consist of 0 odd days. So it is not required to solve. So we have to deduct only 4 days from Sunday to get our answer. So deduct 4 from Sunday, you will get Wednesday as your answer. So you will get Wednesday as your answer. So the answer is option C, Wednesday. Okay. So if 15th June falls 3 days after tomorrow, that is Friday, on what day will the last of the month fall? On what day the last of the month fall? So 15th June falls 3 days after tomorrow, that is Friday. It means 15th of June is Friday. 15th of June is Friday. So last day of the month will fall on which day? So last day of June will be 30th June. So from 15th June to reach 30th of June, we need to add 15 days. And in 15 days, how many odd days are there? Only 1. So we will add 1 on Friday to get our answer, which is Saturday. So there is a problem with the options over here. So the right answer is Saturday. Okay. So the correct answer is Saturday only. Now, next question. The same thing. Okay, do this. Question number 13 now. Question number 13. After this particular topic, we will start syllogism. Okay? Day after tomorrow is Kiran's birthday. On the same day, next week falls Shivratri. Today is Monday. What will be the day after Shivratri? What will be the day after Shivratri? So, today is Monday. Today is Monday. And as per the question, Kiran's birthday is day after tomorrow. So Kiran's birthday is day after tomorrow means this is tomorrow and this will be day after tomorrow. So Monday, Tuesday, Wednesday. So Kiran's birthday is on Wednesday. And on the next week, same day falls Shivratri. It means Shivratri will fall on Wednesday only of the next week. Wednesday only of the next week. So we have to find what will be the day after Shivratri. So day after Shivratri means we will have to add 1 in it to get the day after Shivratri, that is Thursday. So the day after Shivratri is Thursday. So the answer is Thursday. Okay, see this particular question now. This is a good question. If John celebrated his victory day on Tuesday, 5th January 1965, when next will he celebrate his next victory day on the same day? Means John is celebrating his victory day, that is 5th of January 1965, and the day mentioned is Tuesday. So the question is asking when next he will celebrate this victory day on the same day. Okay? Means when next on this particular date Tuesday will fall. So how can we find this particular thing? See, if we talk about, as we know that there are two types of years. One is called a normal year and other one is a leap year. Normal year consists of 365 days and leap year consists of 366 days. So if we talk about a normal year, that how many odd days are there in a normal year? How many odd days are there in a normal year? So for getting the number of odd days, we have to divide this value by 7. So we will get 1 odd day. We will get 1 odd day for a normal year and 2 odd days for a leap year. Two odd days for a leap year. So there is 1 odd day in a normal year and 2 odd days in a leap year. So we have to keep this thing in our mind. For a normal year there will be 1 odd day, for a leap year there will be 2 odd day. So I am writing this down over here. So in a normal year there is 1 odd day and in a leap year there are 2 odd days. So how we will find the next year on the same day? So for that what we will do, we will move year by year. We will move year by year and try to find the days on the same date of the next year. Means from 5th of January 1965 we will move to the next year, means 5th of January 1966. So from 5th January 1965 we have to move on 5th of January 1966. So in between 5th January 1965 and 5th of January 1966, means in between these two dates we need to keep one thing in our mind, that the month of February, which is going to be crossed, is of which particular year? Means it is of 65 or 66. So in between these two dates, the month of February will be of 1965. So from 5th January 1965, when we move to this particular date of 5th January 1966, we will cross the month of February of the year 1965. And since 1965 is a normal year, and as we know that normal year consists of one odd day, it means we need to add one in it on Tuesday. So we can say that 5th January 1966 is Wednesday. Similarly, 5th January 1967. So in between these two dates, the February month is of 1966. 66 is again a normal year, and a normal year consists of one odd day. So we have to add one in it. So this year will be, this day will be Thursday. So 5th January now 1968. Again, the February month is of 1967, which is a normal year, and a normal year consists of one odd day. So since a normal year consists of one odd day, it means 5th of January 1968 will be Friday. Similarly, 5th of January 1969. Now we are crossing the month of February of the year 1968, which is a leap year. And if it is a leap year, we need to add 2 in it, since a leap year consists of 2 odd days. So when we are crossing a leap year, we have to add 2 on the initial day. So the day was Friday. After adding 2 in it, we will reach at Sunday. Similarly, 1970, from 69 to 70, so the February month will be of 69. 69 is again a normal year. So for a normal year, there is one odd day. So we will add one day in Sunday. And finally, if you see that 5th of January 1971, which is again a normal year, and a normal year consists of one odd day. So we can easily say that if 5th of January 1965 is Tuesday, so the next Tuesday on the same day will be of which year? 1971. 1971. So you can also remember or solve it like this also, as we have studied the concept of matching calendar and we discussed about matching year. So we also discussed about the matching year of first year from a leap year. So the calendar of a matching year of first year from a leap year. So the calendar matches after how many years? 6 years. So we can use this particular concept if the year mentioned over here is immediate next year of a leap year. So if it is the first year from a leap year, so its calendar will match after 6 years. So if you see that 1964 was a leap year and this year is 1965, which is 1 year from first year from a leap year. So this year is first year from a leap year. So for first year from a leap year, we have to add 6 in it. So we can directly add 6 in 1965. By this way also, we can directly get the answer, that is of 1971. So the answer is 5th of January 1971, option B. Is it clear? Okay. Next. Hari remembers that his father's birthday is between 13th and 16th of June, whereas his sister remembers that their father's birthday is between 14th and 18th of June. On which day is their father's birthday? On which day is their father's birthday? See. So as per Hari, their father's birthday is between 13th and 16th of June. So in between 13th and 16th, only two dates are there, that is 14th and 15th. It means Hari's father's birthday falls on any of these two dates, that is either 14th or 15th, as per Hari's information. Now, what about his sister? So his sister correctly remembers that their father's birthday is between 14th and 18th June. So as per the sister of Hari, the date is between 14th and 18th, means 15th, 16th, 17th. Since both the information, we need to consider both the information as correct. So as per their knowledge, both the informations are correct. So there should be some common date in it to make both the information correct, and this common date is of 15th of June. So since the two informations are correct, so there must be a common date as per these two information, and that particular common date was 15th. It means we can easily say that their father's birthday is on 15th of June. Okay, next. The Independence Day in 1988 was celebrated on a Wednesday. Okay. On what day was it celebrated in the year 1989? So, this is a very simple question. The Independence Day in 1988 was celebrated on Wednesday. So Independence Day, that is 15th of August 1988, and the day mentioned over here is Wednesday. So the day mentioned over here is Wednesday. So if 15th of August 1988 is Wednesday, then on what day was it celebrated in the year 1989? Okay. So as we know that the difference between these two dates is of only 1 year, and that too, in between these two dates, the month of February will be of 89, not of 88. This time, the month of February will be of 89. Since 89 is a normal year, and a normal year consists of one odd day, it means we need to add one in Wednesday to get the answer, and the answer will be what? Thursday. So the answer of this particular question is what? Thursday. It is quite easy. Let's do it. Why to leave? See, if today is Friday, on the last Monday, the date was 29th of December. So 29th December, 1975. And the day mentioned is what? Monday. Then, and we have to move to Friday, since today is Friday. So since today is Friday, we have to move to Friday. Okay. Then today's date is. So if this date is 29th, this one will be 30th of December, this one will be 31st of December, this is 1st of January, this is 2nd of January, means 2nd January 1976. So today's date is 2nd of January 1976. That is option C. Okay. Next question, question number 22nd. If Friday falls on 15th of September 2000, what will be the day on 15th of September 2001? Again the same question as we discussed earlier. So these were the questions from this particular topic. that is calendar. So let's start our next topic, and the next topic is syllogism. So let's start with this. Okay. So let us discuss the basic of this particular topic, which is very important as per your exams are concerned, and that is syllogism. Okay. So here you will find some statement mentioned over here. So you will find some information written in the form of statement, and which is followed by some conclusions. We need to consider the fact mentioned in the statement as true, and on the basis of the statement we have to verify the informations which are mentioned in the conclusions. So whether as per the statement the given conclusions are true or false. So we need to verify it from the statement. Key that as per the statement whether the given conclusions are true or false. Okay. So for verifying the conclusions, we have to answer the conclusions into three parts. If we are getting an information from the statement regarding the conclusion and we are finding it as true, so then our answer will be true. So if we are getting the information from the statement that the given conclusion is incorrect, then our answer will be false. And if we do not get any confirmation from the statement regarding the conclusion, in that particular case our answer will be cannot determine. Getting my point? So we have to answer the conclusions, we have to find the answer of the conclusions in three parts, whether the given conclusion is true, false or cannot determine. So where there is any confirmation from the statement, our answer will be either true or false. So if we have no confirmation from the statement regarding the conclusion, then only we will use this particular term, that is cannot determine. So let's discuss how to solve a question of syllogism now. We will try to draw the Venn diagram of the statements, and on the basis of the Venn diagram we will verify or check the conclusions. So how many type of statements are there? If we talk about this particular topic, so there are four basic type of statements, and that is sum A or B, I can use the complete board now of the other side as well. Okay. So there are four basic type of statement. One is sum A or B, second one is all A or B, third one is in the form of sum A or not B, and fourth one is no A is B. No A is B. Okay. So these are the four basic type of statements which we usually get in the questions. So the above two statements are called affirmative statements, since affirmative, or you can say positive statements, since Usually if we talk about proper concept, then the first part, the first word, the first thing mentioned over here is called subject and the second one is predicate. But for answering the questions, what we will consider them as two elements. We will consider them as two elements, A and B. So, these two terms, when we talk about sum and all, these two terms are representing a positive relation between the elements. A positive relation between the elements, or you can say a positive relation between the subject and predicate. Got my point? And the two statements mentioned below are called negative statements. So above two are positive, and whenever you find these kind of terms, no, not, never, we will consider it as negative statements. So there are two positive statements and two negative statements. So let's draw the Venn diagram of a particular statement. So see, so that and then discuss regarding the Venn diagram of a particular statement now. So let's start with this. Sum A or B. So how can we draw a Venn diagram for this particular statement? So we will draw it like this. We will draw a circle of A and we will cover some part of A with the circle of B as well. So this is the figure of the given statement. But while drawing the statement, we need to remember one very important thing, or you can say the golden rule of Solox. And that is, a statement never represents the complete Venn diagram. In most of the cases, the statement never represents the complete Venn diagram. It always represents any one part of the Venn diagram. Are you getting my point? A statement never represents the complete Venn diagram. It always represents any one part of the Venn diagram. So if you clearly see this particular Venn diagram, here we have three different parts. Part number 1, which is of only A and not of B. Part number 2, which is of both A as well as B. And part number 3 is of only B and not of A. So here we have three different parts. So the statement sum A or B is not representing all the parts of the Venn diagram. It is representing any one part of the Venn diagram. So we need to concentrate on that particular part about which the statement is giving us the information. So statement is giving information of which of the part. So from this particular statement, we are getting information of which part? Part 1, 2 or 3? Just tell. The statement is giving information of some part of A which are inside B, and that particular part is area number 2. So the statement is giving us information regarding area number 2. So we have confirmation regarding this particular area only. In the whole diagram, we know about only this particular area. So we have confirmation regarding this particular area. So if the conclusion will ask about anything about area number 2, we can give the confirmation regarding that particular conclusion, whether that conclusion is true or false. So we can confirm any information of area number 2 since we are getting information of area number 2 only from the statement. Now, the statement is not giving us information about the remaining part of the Venn diagram, that is area number 1 or 3. We are not getting any information from the statement regarding area number 1 or 3. So if the conclusion will ask us anything about area 1 or 3, we cannot give any confirmation. In that case, we will answer it as cannot determine. So whenever the conclusion will ask anything about area number 1 or 3, our answer will be cannot determine. Are you guys getting my point? Is it clear? So now, come to the second statement. Let's understand the Venn diagram of the second statement. All A are B. So how we will make the Venn diagram of this particular statement? All A are B. So there are two basic ways to draw this particular Venn diagram of this particular statement. One way is like this. We will draw a circumcircle. And the second way is by putting the circle of A. Here the circle of A is at center, but second way can be like this. We will make the circle of A and we will extend it from one of the sides to make B. So this particular part is of A and this whole part is of B. So right now we will follow this particular Venn diagram, not this one. Okay. In both the cases, A is inside B, here also and here also. But here it is at center and here it is at one of the sides of the circle. It is touching one of the sides of the circle. So here we will follow this Venn diagram. This is A and extend it to make it B. So we will extend the circle of A to make B. So if you see this particular figure also, we have two different areas, area 1 and 2. So we have two different areas, 1 and 2. And the statement is giving us information about all A. All A means this particular part, all A. All A means this particular part, that is of area 1. So since the statement is giving us information regarding area 1, means we can give confirmation of area 1 only. Okay. So since we have the information of area 1, we can give the confirmation of area 1 only. And if you see that the statement doesn't give us information regarding area number 2, that is the part of B, so we cannot give any confirmation of the conclusions when the conclusion will ask us about area number 2. So in that case, our answer will be cannot determine. Clear? Okay. Now come to this third statement. Some A are not B. Some A are not B. What will be the Venn diagram of this particular statement? How can we draw the Venn diagram of this particular statement? Some A are not B. We will draw the same Venn diagram as we did for the first statement, that is some A are B. But if you can clearly see that this particular statement is an affirmative statement, or you can say a positive statement, but here it is a negative statement. Okay, it means figure is same, but it doesn't mean that both the statements are same. Their figures are same, but the statements are not same. In the first statement, here the statement is giving information about some part of A which is there inside B, and that is of area number 2. But in this particular case, we are getting the information of some part of A which are not in B. Some part of A which is not in B means here we are getting information regarding area number 1. Here we are getting information of area number 1. So since we got the information of area number 1, means we can give confirmation of area number 1. But as from the statement we are not getting any information regarding these two areas, means 2 and 3, it means we cannot give any confirmation about this particular part of 2 and 3. So if any conclusion will ask us about area number 2 or 3, we will answer it as cannot determine. As we do not have any information from the statement about these two areas, we cannot give any confirmation of these two areas as well. So you can see, if you see properly, you can see that we have no information regarding complete B. So from the statement we are not getting any information regarding B. We are getting the information of some part of A, that is outside B, and we are not getting any information regarding the rest of the parts of B and A. Now come to this last statement, no A is B. What will be the Venn diagram of this particular statement? So here we will make it like this, A and B, and we will draw a line in between it and put a cross mark on the line. This cross mark and this line and cross marks represents that A and B cannot touch each other. A and B cannot touch each other, means this distance will always be constant when we talk about A and B. So this statement is giving us information regarding which area? So no A is B, means A will not touch B. It means we are getting an information of area number 1. Area number 1 will not touch area number 2. So if area number 1 will not touch area number 2, we can also say that 2 cannot touch area number 1 as well. Both of them cannot touch each other. So this is the only term no, which gives us information about the complete Venn diagram. Here we are getting information of 1 and 2 as well. So we can give confirmation regarding these two areas. So any conclusion, if any conclusion is asking us about 1 or 2, we can confirm the conclusion by answering it as true or false. So here you will not find a case of cannot determine. Okay. Since we have information regarding the complete Venn diagram, we will give confirmation of the complete Venn diagram. So where we are not getting the information of complete Venn diagram, so we need to see that the statement is giving us information of which of the parts of the Venn diagram. We will give confirmation only about that particular part only. Okay. So these are the 4 figures. Apart from these 4 figures, one more figure is there which we have to consider, and that is this particular figure. Students usually get confused between these two figures. There is a difference between these two figures, and that particular difference is what? There is no line in between these two figures. So if there is no line between any two figure and they are separated, means area C, A and B, these two are separated, and if there is no line in between A and B, it means we have no confirmation between A and B. We cannot give any confirmation between B and A and B. So the relationship between A and B is unknown. So whenever we find two distant circles and no line is there as such like this, it means what? We cannot give confirmation of any conclusion between the two. So if we get any conclusion between the two figures, our answer will be straight away cannot determine. So since we have no information between these two figures A and B, In that case, our answer will be cannot determine. So I hope so these 5 figures are clear to you people. Now, let us understand some more thing over here. See, in case of syllogism, some of the statements are contradictory to each other. So we need to know that which of the statements are contradictory of each other. Contradictory means just opposite. Opposite means if one of the statement is true, means the other one must be false. If one is true, the next one should be false. If the second one is true, it means the first one is definitely false. So, contradictory terms. Which of the terms are contradictory? The first contradictory pair is of some and no. Means some A are B and no A is B. These two statements are contradictory to each other. Okay? These two statements are contradictory of each other. Similarly, second pair is all and some not. These two statements are also contradictory to each other. Means all A are B and some A are not B. These two statements are contradictory to each other. Contradictory here means if any one is true, means its contradictory is definitely false. If this one is true, then its contradictory term is definitely false. So these two are contradictory statements. So, and if the answer of any one is cannot determine, it means the answer of their contradictory statement is also cannot determine. So, answer of any particular term is cannot determine, it means their answer of their contradictory statement is also cannot determine. And if we get the two conclusions which are contradictory to each other and the answer of them are cannot determine, so we can combine those two conclusions by using either and or. So whenever we find two conclusions, two contradictory conclusions, and the answer of both the conclusion is cannot determine, we will combine them using either and or. We will combine them using either and or. So these are some basic concept or rules which we have to follow to solve a question of syllogism. So let's move to the question to make our understanding even better and to know how to approach any particular statement or conclusion. So what we have to do with the statement and what we have to do with the conclusions, how we will try to solve the conclusions, let's see that. See, come to the first statement now, statement number 1. Prashant, we will discuss the concept of either or with an example also. So not to worry, we will discuss it. So when we start discussing the questions and their answers, you will get to understand it very easily. Okay, Mr. Prashant Kumar Kapila. So let's start with the first question now. How to approach a particular question? Let's see here. So the first statement is all windows are doors, all buildings are doors, and all doors are board. So we will draw the Venn diagram of the statement. All windows are doors. All buildings are doors. And all doors are board. All doors are board. I think the class is till 2 p.m. Vaibhavi. Class is till 2 p.m. So we have enough time. Not to worry. So we have made the Venn diagram. Now you can put the numbers if you want. This will make your things quite easier. That's why I'm saying. So we will put the numbering. Random numbering. You can put random numbering on different areas. There is no issue with that. Means it is not necessary to start it from here. You can start it from here also, here also, here also by putting 1, 2, 3, 4. Okay? Okay. As per the schedule, the class is still 1. Okay. So let me confirm it first. So no issue. I'll take your class till 1 p.m. only. If till 2 p.m. then it would be the longest class we ever had. Okay, class of 5 hours. Okay. So let's come to the conclusion part now. Let's see how to verify the conclusion. Come to the first conclusion. All windows are board. All windows are board. Conclusion number 1. I am writing in short. All windows are board. C. Yeah, 5 hours. But I have taken the longest class of 12 hours. From 8 in the morning till 8 in the evening. 8 to 8 of 12 hours. So let's come to the topic now. See, what is the area of window now? So the area of window is area number 1. Okay, it is till 1 p.m. only. Okay. So your class will be till 1 p.m. Fine, na? Okay. So all windows are board. So area of window is 1 and that of boat. This is boat. Boat means this, the larger circle. The larger circle is accommodating all the numbers 1, 2, 3, 4. It means for boat, these 4 areas combine together to make okay. Okay, but not according to schedule. Okay. Thank you, beta. So come to this particular question now. So all windows are boat. So window consists of area number 1 and boat consists of area number 1, 2, 3 and 4. All window means all the area numbers of window should be in boat as well. To make this conclusion true, all the area numbers which are mentioned in with window should be common in boat as well. So if it is common, it means it is true. If it is common, it means it is true. So see, all the part of window consists of area number 1, and we are finding it in boat as well. Area number 1 is there in boat also. It means this conclusion is true. It means this conclusion is true. Okay? Yeah. Due to some means health issues, I could not take your class yesterday. Sorry for that. So come to second conclusion now. Second conclusion is all buildings are boat. Again, we have to do the same thing. Building consists of area number 3. If this area number 3, which is of complete building, is there in boat as well, you can see this area number 3 is there in boat as well. If it is in boat also, it means this conclusion is also true. If it is there in boat also, it means this conclusion is also true. Now come to the third conclusion. And this third conclusion is what? Some boats are door. Some boats are door. See, whenever there is a term some in the conclusion, we have to check only one thing. Is there any number common between these two elements? Is there any number common between these two elements? If at least one number is common between the two elements, it means this conclusion is also true. Now we can easily see there are three common numbers in between boat and door. It means some boats are door is also true. So for checking the conclusion of some, we have to check at least one part should be common between boat and door. And if it is there, it means it is true. And if we have to check, when we have to check all, what we have to check that all part of the first element should be common in the second element. All part of first element should be common in the second element. So when the conclusion is of sum, it means at least one part of first element should be common in the second element. And when there is a term all, it means all part of first element should be there in the second element as well. Then only this conclusion will follow. So here all the three conclusions follow. So the answer is all follow. So answer of this particular question is what? All follow. Now come to the second statement. Some radios are telephones. So some radios are telephones. All telephones are mirror. All telephones are mirror. Yes. Sir, please once explain how do you plot the numbers. See, the figure was like this: window, building, door, and boat. See Mani, the figure is like this. You can start putting the number from any of the part. It totally depends upon you. So each of the different parts should, the only thing which you have to keep in your mind that each of a different part should be allocated a different number. Should be represented by a different number. Like if in this particular case, if the conclusion is some windows are door. So part of window will be 1 and that of the number inside the circle of door is, inside the circle of door, 1, 2, 3. So if the conclusion is of sum, we have to check at least one number should be common between the two elements. Is there any number common between the two elements or not? So we are finding one number common. It means this particular conclusion holds true. Similarly, if the conclusion is like this, that some buildings are door. So the part of building is 3 and that of door is 1, 2, 3. Some means any one, at least one number should be common between the two elements. And you can see there is a common number between the two elements. It means this conclusion also holds true. But if the conclusion is like this, that some window are building, some window are building. So part of window is 1 and that of building is 3. So there is no common number between window and building. If there is no common number between window and building, means the numbers allocated to them are uncommon. It means we cannot give any confirmation regarding the two, regarding the relationship between the two elements. Since there is no common number between the two elements, it means we cannot give any confirmation regarding the two elements. And in that particular case, the answer of it will be what? Cannot determine. In that particular case, what we will answer it as cannot determine. So let's move to the second question. Money, is it clear to you now? You can start putting the numbers from any of the part. It is not necessary that you should put 1 over here, 2 over here, 3 over here. You can put any number at any particular part. Okay, next. Some radios are telephone. So this is radio and this is telephone. Next, all telephones are mirror. All telephones are mirror. And third is all mirrors are desk. So we have to extend mirror to make desk as well. So now start putting the numbers. These numbers will make your thing easier, a lot easier, or you can say less confusing also. Now come to the conclusion. First conclusion is what? First conclusion. Some radios are desk. See, when we talk about radio, radio consists of this particular circle. So the numbers inside this circle is 1 and 2. And when we talk about desk, desk means these whole part means 2, 3, 4, 5. So we can clearly see that there is a common number in between these two elements and that common number is 2. So if there is a common number between the two elements and the conclusion is asking us about sum, so our answer will be true. So the first conclusion of the second question is also true. Now come to second conclusion. Some radios are mirror. Again we have to do the same thing. Since there is a term sum, means we need to check whether there is a common number between these two or not. So radio consists of 1, 2 and mirror consists of 2, 3, 4. So again we found a common number. So if there is a common number, means this is also true. And third, some desks are telephones. Some desks are telephones. So desk part is 2, 3, 4, 5 and telephone part is 2 and 3. This particular circle consists of telephone 2 and 3. So we are getting two common numbers. So if at least one common number is there between the two, then this particular conclusion is true. So here also the answer will be same. What? All follow. Here also the answer will be same. All follow. Now come to question number 3. Oh shit. Yes. Question number 3. Try to solve this. See, there is a negative term. So whenever there is a negative term in the statement, we have to keep one thing in our mind, that we should note down the negative relation between the elements, or we should note down the specific areas of the negative relations. Means which of the two areas are having a negative relations. We should mark it also. Okay. So let's draw the diagram first, then we will understand it further. Like all minutes are seconds. So this is minute and this is second. All minutes are second. Second statement is all seconds are day. Okay, all seconds are day. So this is day. And third is no day is night. No day is night. No day is night. So we will put cross mark to represent no. No means what? No means there is a negative relation between day and night. Negative relation between day and night. So we should specify the area among which of the areas there is a negative relation. So area of day and night. So day consists of all the three, 1, 2, 3, and night consists of only 4. So there is a negative relationship between 1, 2, 3 and with 4. There is a negative relation between 1, 2, 3 with 4. Is it clear? Now, let's come to the conclusion part. Some seconds are minutes. Some seconds are minutes. So since second consists of these two areas, 1 and 2, and minute is only of 1, there is a common area. We are getting a common number in between these two elements. It means this is true. Second, some days are not second. Some days are seconds. Some days are seconds. So part of days are 1, 2, 3, and second is only 1 and 2. Some means one area should be common. So here we are getting two common areas. At least one should be common. If we are getting more than one, means the case of sum is true. Now, third, come to conclusion number 3. No night is day. No night is day. See, the part of night and day. Part of night is 4 and that of day is 1, 2, 3. We have to check this thing, no. No means a complete negative relation between the two elements. No here stands for a complete negative relation between the two elements, means there should be a negative relation between 4 and 1, 2, 3 to make this conclusion true. So to make this particular conclusion true, all the parts of n should have a negative relation with all the parts of d. Then only this conclusion will be true or follow. So can we check there is a negative relation between 4 and 1, 2, 3 or not? Yes, there is a negative relation between 4 and 1, 2, 3, which means this conclusion is also correct. This conclusion is also correct. Now come to question number 4. Sorry, conclusion number 4. All minutes are days. All minutes are days. So part of minute, that is the area of minute is 1 and that of day is 1, 2, 3. All means all part of minute means 1. If 1 is common in day, it means it is also correct. Means it is also true. Yes. So all the conclusions here also are true. So the answer is all follows. All follows. So answer will be D. Yes. All 1, 2, 3, 4 follows. Now come to question number 4. 4 now. Some teachers are professors. So this is teacher and this one is professor. Some teachers are professors. Some lecturers are teachers. So some lecturers are teachers. So here we have 5 different parts. All conclusion is all teachers are professors. All teachers are professors. Let's check this. Teacher here stands for 2, 3 and 4. And professor here is only 4 and 5. All teachers means all part of 2, 3, 4. Means this 2, 3, 4. All the 3 areas, whether it is common in P or not. Only 4 is common. Since 2 and 3 part are not there in professor, means 2 and 3 part is uncommon. And if it is uncommon, it means we cannot give any confirmation regarding the uncommon part. Why so? To make it a positive relation, it should be common. And from the statement, we are not getting any negative information. Means there is no positive relation in between these two, since all the area is not common. And there is no negative relation in between these two. Means we cannot confirm the exact relation between the two. We cannot say whether all T are P or not. Cannot confirm it. So that's why the answer is cannot determine. Okay, second is all teachers are lecturers. All teachers are lecturers. Here also the same thing is happening. All teachers means all part of teacher should be common in lecturer. Only area 2 is common. 3 and 4, since these two areas are uncommon areas, and we cannot give any confirmation regarding the uncommon areas. So this 3, 4 has neither a positive relation with L nor negative relation. It means we cannot confirm it. That's why the answer will be cannot determine. Okay, now come to this third part, that is some lecturers are professors. Some lecturers are professors. Some lecturers are professors. So lecturer part is 1 and 2 and professor part is 4 and 5. Again, there is no common number in between these two. So if there is no common number between these two, means we cannot confirm the relationship between them. So that's why here also the answer will be cannot determine. Now come to fourth. Some professors are lecturers. Some professors are lecturers. So part of professor is 4 and 5 and that of lecturer is 1 and 2. Again, we are not getting anything common in between these two. So these two areas are totally uncommon, and uncommon areas, in case of uncommon areas, our answer is what? Cannot determine. So the answer of this question also is cannot determine. Means the answer of this question is now none follows. Since no conclusion is true over here, so that's why the answer is none follows. Or you can say none of these. So the answer is D, none of these. None follows. Is it clear? So if none of these is none follows is not mentioned in the option, we will go for none of these. We will go for none of these. Now come to question number 5. Let's see the fifth question now. Okay. All cats are dogs. See, this one is cat. All cats are dogs. And all dogs are pen. All dogs are pen. All cats are dogs and all dogs are pen. Conclusion number 1, all cats are pen. So cat consists of area number 1 and pen is complete areas is 1, 2 and 3. All cat means all part of 1. If 1 is common in pen, it means it is true. All cat means area number 1. If 1 is common in P, it means it is true. But the second conclusion is all pens are cats. All pens are cats. So here all pen means area number 1, 2, 3. All the 3 parts should be inside cat. We are finding only area number 1 here. Since 2 and 3 are not there in cat, it means this part is uncommon, and for any uncommon part we cannot give any confirmation. So here the answer is only first. Only first. So first one is true, but we cannot give any confirmation about regarding the second conclusion. Getting my point? So here answer will be only 1 follows. Only 1 follows. So come to question number 6. Some wires are telephones. Some wires are telephones. All telephones are mirrors. All telephones are mirrors. All mirrors are desk. All mirrors are desk. Now come to conclusion. Some wires are desk. Some wires are desk. See this. Part of wire is 1 and 2. And that of desk is 2, 3, 4, 5. The term is sum. Sum means at least one area should be common. At least one area should be common. Since there is a common area, that is 2, it means this conclusion is true. Very good. Rupali, Suraj. Now come to second conclusion. Some wires are mirrors. Some wires are mirrors. So wire part is again 1 and 2, and mirror part is 2, 3 and 4. Again the term is sum. Sum means at least one area should be common. So there is a common number between the two. It means this is also true. This is also true. And come to the third conclusion. Some desks are telephones. Some desks are telephones. Desk part is 2, 3, 4, 5. 2, 3, 4, 5. And telephone part is only 2 and 3. Telephone part is still this particular circle only. Okay. So again the term is sum means there should be at least one common number. Since we are getting two common number, it means this is also holds true. This also holds true. So here the answer will be yes, all 1, 2, 3 follow. All follow. So answer of this question is all follow. Option D. I hope so you understood all the things which we discussed today. Okay then. So that's it for the day. Thank you very much. See you tomorrow, and we will discuss this topic further in the next class only. Thank you very much.